Hi, in today's video we have a Milwaukee job site DAB Plus radio. It looks like it's got a bit of an unusual fault. If I switch it on, the display will come on. It was described as basically when I bought it off eBay for spares or repair, it said that the front panel buttons weren't working. Now, if I try it on the battery, the buttons do appear to work, and you can change the mode and whatever. And you sometimes get, oh, it's just crashed there. You sometimes get sound out of one of the speakers. If you plug it on mains, it just basically crashes as soon as you start turning the volume up. I mean, I've turned it back off there. If I turn it on, it'll come on. The two little, the little colons flashing there on the clock. You can change the mode. You can go into the menu and things. And it doesn't seem to crash, but as soon as you try and turn the volume up slightly, and you see it's just froze up now. It's just locked up. So what we'll do is we'll figure out how it comes apart. I'll remove the battery. Now, on the sides it's a T20 Torx. So what I'll do is I'll just remove these two side panels first. Right, what we've got now. I see a couple of small Phillips screws on the front. So I shall just grab my Phillips driver. And there's one. And there's two. Right, looks like there's a couple of small Phillips, actually no, they're Torx. Okay. Right, can we see any more screws anywhere? Right, looks like it's held at the top somewhere. Right, there's a load of screws. Yeah, they look like Phillips. A load of Phillips screws down this side as well. Right, is it going to come apart now then? Yes. Right. Looks like there's a small daughter board here. Looks like I might have to unsolder that one. I shall put that iron on. Right. And we'll move this a little bit further back so you can see. Okay. Right, so what I'm going to do now is remove these silver screws here, which looks like hold the main board in. Hold up the main board. Right, let's just remove these two top ones. Which flanges and all those on it. Right, just come out now. Right, we got supplies on there. Right. There we go. Right then. So that's the speaker plug. So what have we got here then? Right, I think it's worth getting the microscope in just to have a quick look over this board, see if we can see anything obvious. I can't see anything on the back. I've got this little, I guess that might be the DAB module on the of the radio, and I guess this must be the FM and whatever around here. All the buttons seem to work correctly. Right, so I've just been looking up the information on these three chips here. Now, this one here, the MC96F8208, that's a CMOS single chip 8-bit MCU with 12-bit analog to digital converter. So basically this thing here must be the brain of the unit. That's like a little microcontroller. So I guess that's responsible for running the display and everything. The next chip, which is this one here, which is an SC7314S. Apparently that's an audio processor and a volume control. Now, one thing I did notice is the thing seems to crash when you turn the volume control, and also there seems to be this resistor here looks a little bit suspect, so I wonder if it's something to do with this chip here. This next chip just below that, the TDA 3130 or TPA 3130 rather, that's a 15 watt stereo amplifier. Now the fact that I was just getting sound out of one speaker occasionally, I would suspect it's one of these two chips that's probably at fault, because before you turn the volume up, the microcontroller runs perfect, but as soon as you get past a certain volume, then, or as soon as you try and turn the volume up even slightly, the whole thing either crashes, or sometimes you do get sound out of one speaker but not both. Tell you what we can do, I'll just move this board just to one side for now. I'll just double check that the speakers are actually working, just in case there's, you know, it's as simple as a blown speaker on one of the things. I mean, that wouldn't stop the, that wouldn't cause it to crash, but let's just check. It's about 10 ohms. What size are these speakers? It doesn't actually tell you what ohms there should be. 12 ohms. Yeah, 12 ohm speakers, so what's that measure? 10.8, yeah, it's about right. And what's this one? 10.4, yeah, so I'd say that both the speakers are actually okay. I wonder if I can get this thing connected back up and measure some voltages on it. Right, tell you what. Just give us 2 seconds, I'll just pause the video, I'll try and set this up so it's kind of connected and working, and we'll see if we can measure some sort of voltages on it. Right, I've got it kind of set up there so we can measure some voltages there now. So I assume that this metal shielding, I shouldn't handle these probes here. I would assume the metal shielding here is going to be ground. So I've got a, that looks like a little voltage regulator there. So 2.1 volts on there. There's about 3.3 on there, so that looks about right. I'm not sure about the 2.2 though. That's more like it, 1.8. Yeah, 1.8 is a common voltage and 3.3, so... Now, on the schematic of the pin out of this chip here, I think that pin there is the power. There doesn't appear anything going to there. I wonder if it is when we switch it on. Right. Yeah, 16 volts going to that chip. I don't know if that's a bit high or not. I don't know what the voltage of that chip's supposed to be. Looks like there's another big regulator down here. Yeah, there's a 5 volt there. 5.5 volts. It's actually getting quite warm, that one. Yeah, there's a fair bit of heat coming from that one. Yeah, see, I've just turned the volume up slightly there now, and the and it stopped flashing. I'm just going to pull up the data sheet on this chip here just to see what voltage. I mean, it's a little bit warm, but it's actually it's quite warm at that end. Right, let's pull up this data sheet for this this chip again. Right, so I've just had a quick look at the data sheet on this chip, and the supply voltage does come up on that pin there, on pin 1, and the average is supposed to be about 9 volts, maximum of 10. So let's see if I can find out where the ground is. The ground's just the pin below it. So we'll just see if we can get our probes on those without shorting anything out. We've got 15 volts on there. So I'm just wondering if that's a bit high. I wonder if there's a voltage regulator or something gone somewhere. Well, then again, that little resistor there, let's say, looks a bit burnt. So let's see what voltage we've got on that side of it. 19 volts, 15 volts. So it is actually dropping it a little bit, but yeah, so I'd say that's probably supply straight from either the battery or straight from the power supply. So I wonder if it needs a bigger resistor in there. As I say, it definitely looks burnt, that resistor. What I'll do is I'll disconnect this. I'll bring the microscope in. We'll pull that resistor. We'll try a different one, and then we'll see see what happens. But that chip definitely, yeah, it's quite hot, that. So whether or not that chip's blowing, yeah, that's a bit definitely a bit hot. So whether or not there's too much voltage going into that chip and it's blowing it. That's what I kind of suspect. The other chips are fine. They're quite cool. And the fact that I was only getting one, I mean, it kind of makes sense because this chip is controlled from the microcontroller via IC squared. So, I squared C rather. So I think what happens is, you turn the volume pot, it actually sends the signal to the microcontroller, and then the microcontroller controls the volume via this chip here. Yeah, definitely getting very hot, that chip now. So what I think's happening is, when you turn the volume, you're sending the signal to the microcontroller, it's then sending the signal to control this. This is obviously having a problem, some kind of malfunction, because it's getting, let's say, extremely hot now. I'm just going to switch this off. And I think that's causing the microcontroller to crash. So I think what we'll do is, I'll see if I can get a replacement chip, and I'll try and find out what that resistor is. We'll get the microscope out of the way now. So, there's the chip off, and that's where it was on the board. I'll just bring that closer to the camera there so you can have a look. So that's where the chip's been removed, just here, and that's where the resistor was removed. So what I'll do, I shall go and try and order some replacements. I might actually try a bigger resistor in there, like I've said, a bit higher value and a bit beefier one, because like I said, it just didn't seem. I wonder if there's some kind of design fault on these. But anyway, we'll give that a go, and then we'll see what happens in the next part of the video. Right then, so I soldered the new chip in with the resistor on the back of the board, and the resistor started smoking, so almost immediately when I put the power on. So I thought, well, that's a bit odd. So what I've done is, I tried measuring the resistance of the input of the power on the original chip and compared it to the two chips which I ordered from China. Now, if I just put these probes onto the power, this is the original chip. I'll put the probe on the power here and on the ground. We've got a reading of about 105k there. If I do it on these chips, which are the two replacements that I bought from China, about 450 ohms on that chip. And if I do the other one, again, about 430 ohms. So, I'm not sure if these chips are fake. There's just, I just don't understand why you'd have two chips with completely different resistance readings to this one here. So, what I did was, I ordered the other chip. That's the replacement chip there, which I believe is a Princeton Technology 2314, which is equivalent to the original chip. But what I found out was basically the microcontroller here sends a signal out round about one of these pins here. It comes down, it ends up coming in on this resistor here, and it switches this transistor on and off, which with a little Zener diode here, which regulates this transistor here, and that sends 9 volts up to here through this transistor here and along that line, and ends up on the pin there. And actually, well, it ends up coming through this resistor, or used to come through that resistor, and ends up powering the chip. Now, originally, this was kicking out 19 volts, so it wasn't actually being regulated properly. And it turned out, I think it was this diode here. I bought another Milwaukee radio, and the circuit board was actually good in that one. I think there's a problem with the power supply on the other one, so I'll do a repair video on that at some point. So I ended up swapping some components over, and this resistor here, sorry, this diode here seemed to be faulty, so I replaced that, and then we started getting 9 volts out of this chip. What I did was, instead of trying to solder a new resistor on there because the pads were a bit burned as well, I actually soldered a resistor across the back. I put a slightly bigger resistor in. I think it was about a 50 ohm or so resistor I put in there, 47 ohm possibly. So, and basically it sends the power along the same path as what the original resistor did. So what we'll do is we'll power it back up, we'll check everything's working, and then we'll reassemble it. Right, so I've got the test meter set up here. I've got the radio in some sort of assemblage so I can actually power it up. I'll just switch it on here. I've just got it on FM. I haven't got the aerial connected back up at the moment, but well, there we go. It seems to be working now. So if I just measure the voltage to the chip here, as you can see, we've got about 7.76. Like I say, because I've dropped it a little bit more through that resistor, but the voltage range apparently is between, I think it's 5 and 9 volts. So I say that'll be fine. And if I measure just on this little transistor here, and there's one 9.27, and then coming out of that, because it drops it slightly, we've got about 8.53. So yeah, so the regulator circuit here is actually working now. So I think we'll get it back together, we'll reassemble it, get it back together, and then yeah, I think we'll call this one a fix. So I've came up out the house to try and get a signal, because where we live we don't get very good DAB, if any at all, and also the radio signals are very good. So I've brought the radio outside just to get a signal.
So we can stay in bed, guys.
Head to absoluteradio.co.uk to nominate your bad guy.
And I do what I want to do.
So there you have it, and it works on FM as well. I'll just go on to FM there.
Justice has done some research, and it calculates that more than 1 million people in England alone are currently borrowing from unlicensed lenders.
So yeah, another successful repair. So if you like these videos, please subscribe. If you want to see more like them, or if you've got any questions, please leave them in the comments below. And as always, have a great day.